Okay. Centers of triangles. Okay. Our first one here is called the circumcenter. And the circumcenter is where the perpendicular bisectors of the sides of a triangle intersect at a point called the circumcenter. Okay. The circumcenter is always equidistant from the vertices of the triangle. Okay, so let's look at our picture and talk about what this means. Okay, so the perpendicular bisectors of a side, okay, are the segments that cut a side in half and are perpendicular to that side. So, for example, can somebody give me the name of one of those perpendicular bisectors? Say that. It needs two letters, so I know which. You're probably right. DP. Right here. So, DP, right here, that would be, and when we name this, we're going to do DP with a line over top to say line segment DP, or PD. It doesn't matter which order you put those letters in. Okay? Okay, this is something a little different than what you've done before, so maybe it will be all right. Then, who can name another perpendicular bisector here for me? Aiden? PE. So this one right here, PE. Not BP. That does not cut a side in half. FP. Okay, so let's look at these so everybody understands what those are, okay? They are the pieces that are perpendicular to the sides, and they cut those sides in half. So, like, for example, right here, DP is perpendicular to this side, and it's right there at the midpoint where it cuts that side in half. So this piece is equal to this piece, okay? So, a circumcenter, if we know we have a circumcenter of a triangle, it is helpful because it tells us lots of pieces of that triangle are equal to each other, right? So, so if you have these three intersecting here, they intersect at that point in the middle. That is your circumcenter. So, point P would be your circumcenter. And so there are going to be several pieces of this triangle that are congruent. Have you guys seen this symbol for congruent before? The equal with the squiggle over top of it. Yeah, so that means congruent. So like, for example, AD would be congruent to BD. Right? So this piece right here, AD, is congruent to BD. Yes. No. The lines that go to the corners are not perpendicular bisectors on this. They're going to have something special we're going to talk about here in a second, but they are not perpendicular bisectors. So it's got to go from that middle to the side, and it's got to be perpendicular. One way we can know, like, AP is not a perpendicular bisector is it's not perpendicular to anything. Like, you don't have a right angle anywhere for that. So it's not the perpendicular bisector. Can somebody give me another set of pieces of segments that are going to be congruent to each other? Let's see. CE and BE. Yes, perfect. CE and BE are congruent to each other. And they're marked here with those like little three tick marks here and 3 tick marks here, that's showing us that they're equal to each other. But even if they didn't have that there, since we know P is the circumcenter, we would know that those two are congruent, even if it's not marked. AF and FC. Okay? All right, now the reason that they even drew in these lines here, let's switch to this AP, BP, and let me switch colors. Let me make all those pink right there so that you don't get confused on it. So like all three of these pink lines right here are perpendicular bisectors. They are not equal to each other. They could be in a perfect world, but they're not in this triangle. However, these yellow lines right here, those are all equal to each other. They are all congruent. Okay? Whenever you have a perpendicular bisectors connecting here at the circumcenter, that circumcenter, it tells us right here, is equidistant from the vertices. So these lines right here that go from the center to the vertices, which the vertices are your corners of your triangle, these three lines right here are all congruent to each other. So we want to add down here on this bottom line, AP would be congruent to CP, which would be congruent to BP. All three of those are congruent to each other. So what happens for a lot of these is they are going to give us triangles. We're going to either be told that it's a circumcenter, or we'll have the information we need to know to recognize it's a circumcenter. And we're going to they'll give us like different pieces of sides, and we'll have to find the missing parts for that. So everybody got everything down for that slide? All right. So let's look at a problem. It's fuzzy. Sorry about that. This is the best I could do. These without having to redraw all of these. So it tells us W is the circumcenter of triangle QRS. Find each measure. All right, I like to go ahead and do everything I can do before I even start worrying about what they're asking me for here. So if this is my circumcenter here, that means that this is a perpendicular bisector. The bisector, what does it do to that side? That word bisect, what does it mean? Cut in half. So if this is 21, what's this? Also 21 right here, right? Here would be another perpendicular bisector. So if this is 19, what's this side? Another 19, right? This is a perpendicular bisector here as well. They didn't give me the length of either one of these sides, but they did give me the whole side. So what would the length of just one piece be here? Just 16. 16 here and 16 here. Okay, there's a couple more lines here that we can find, because I should know the circumcenter is always the same distance from the vertices. So right here from the circumcenter to Q, that's 24. So what other sides would be 24? What? WS is also 24. What else? There's one more. Not WU, because that doesn't go to a vertex. WR goes to a vertex, so 24 would go right here as well. So whenever you're looking at those three that are the same there, it's from the center to the vertex. This is center to the vertex, center to the vertex. Those three right there are the same. These three here, the perpendicular bisectors, they're not usually the same. They could be in like an equilateral triangle maybe, but they're not on this one. All right, so let's look at what they've asked us for. I've labeled a lot of these. So if I want RS, RS is this whole side. What have I got to do to find RS? Not 32, that's RQ. 19 plus 19. So from R down here to S is 19 plus 19, which is 38. Okay? TQ, we already labeled right here. From T to Q, we said that was 16. WS, that one was 24. Q to V, 21. TW, oh, we don't have that one labeled. We can find it, though. These last two are going to be just a little bit harder, but still not that bad. Where'd you get 8? No. What kind of shape do we have right here? It is a triangle. Isosceles means that two sides are the same, and we don't know that for sure. So we can't make that assumption. Although it does kind of look like RT and TW are the same, but we can't make that assumption. I like what Anissa's saying over here. What is it, Anissa? That's a right triangle. In a right triangle, if I've got 2 of the 3 sides, I can do something to find that missing side. What is it? Pythagorean theorem. Okay? So, A squared plus B squared equals C squared. Which side is my C there? The 24. It's always across from your right angle. It's your longest side across from your right angle. So you would have 16 squared plus x squared equals 24 squared. 16 squared is 256. I think 24 squared is 576. Is that right? You will need to subtract your 256. So x squared is going to be like 320. Okay, what's the last thing you need to do here? Square root. And what do we get for square root of 320? Because I definitely can't do that in my head. It's going to be a decimal. 8, 8, 8, 5, 4. So that, if we round it to 3 decimal places, 17.889. Okay. Questions on that? All right. Let's look at the next part. WV. This piece right here. We don't have it. How are we going to find it? Pythagorean theorem again, right? I'm going to call this maybe like a y. I don't want to use the same variable as I used before. Which side there is my hypotenuse of that triangle? The 24 still. So it's going to be 21 squared plus the y squared equals 24 squared. Say 21 squared. $441 plus y squared equals 576. We'll subtract that 441. We get 135. And then we must square root both sides. So square root of 135 is going to give us 11.619. Round to 3 places, so 11.619 for that. This is about, as far as these questions go, unless it has maybe an X in the problem, this is about the most difficult thing you're going to have to do to find them. The steps are going to be pretty basic. You're usually just doubling something, cutting something in half, recognizing that these two are the same, or possibly doing Pythagorean theorem on these types of problems for that. So it's the understanding which one of those you need to do that is the more difficult part of this. Okay, questions? All right, I got one more question on a circumcenter, and then we got to move on to some others. All right, so sometimes I like to throw some algebra into the geometry problems, just to make sure you still know how to do a little bit of algebra. So it tells us that P is the circumcenter of triangle ABC, and we're supposed to find the measure of BC. So BC is the length of this whole side here. Didn't mean to do that. Well, here we go, BC. Here's what we're looking for. If this is a circumcenter, that means we have perpendicular bisectors going out from that circumcenter there. The perpendicular bisectors cut each side in half, meaning that this piece is going to be equal to this piece, correct? So that means 13x minus 51 has to be equal to 10x minus 33. So, Carlos, if I want to solve that equation, what do I need to do? Good. And how am I going to do that? Okay. And to move it to the other side, what have I got to do? Subtract. So I'll subtract 10x there. So I'll get 3x minus 51 equals negative 33. William, what would I do next? What? Add the 51. Good. So 3x equals, is that 24? I think. And then divide by is 18. Oops, sorry. Uh, 18 divide by 3. And so x is 6. You feel like you're done here, but did it ask for x? No. What did it ask for? It asked for measure of BC. So what do I need to do? I need to plug 6 back in, right? It doesn't matter either one of these right here. You can plug it in. I'm going to do this one. It looks easier. 10 times 6 minus 33, which is 60 minus 33. Which is going to give us 27. So if this piece right here is 27, this piece is also 27. And 27 plus 27 is going to give us 54 for that. Okay, questions? All right. Okay, let's learn about another one. Our next one is called the incenter. Okay, you can see how these are going to start to get easy to get mixed up. So that's why we were going to make sure we put all of the stuff on our note cards so we can refer back to it. Because even it's been a while since I taught geometry. For a long time, I taught mostly geometry. But it's been a while, so sometimes I can't remember which is which. All right, so the incenter is where your angle bisectors are going to cross. So angle bisectors. So let's think about what that sounds like. What does it sound like an angle bisector does? Divides an angle in half, right? So it is going to be, your angle bisectors are going to be this line this line and this line. Those lines that cut your angles of the triangle in half. So for this problem, it is BP, EP, no, not EP, CP, and AP. Oh, wait. I did not fill in this blank up here, did I? The end center is always equidistant from the sides of the triangle. So for this, P is our end center. So, whenever we have an end center, these three lines are not equal to each other necessarily. Would be in an equilateral triangle, but not in most others. So these are not equal to each other. However, the end center should always be equidistant from the sides. So these perpendicular lines right here are your length to the sides. If you are wanting to go from a point to a side, the perpendicular path is your quickest path to get there. So this would be the distance here. Now, are those perpendicular bisectors? Do they cut the sides in half? It looks like it over here, right? But does it look like it over here? No. These are not perpendicular bisectors. This is just the length from that end center to the edge is what we're seeing. Those three right there are equal to each other. So that would be DP is congruent to PE, which is congruent to PF. So those three I have highlighted there in yellow are congruent to each other. You can mark them with one little tick mark there to show they're all the same. It says list all congruent segments, and technically angles are not segments. But I would also like to note that you're going to see this sometimes, M angle DBP. That M before it means measure of the angle DBP. And whenever I name an angle, like for example, if I'm trying to name this angle right here, this little angle here, I need to use three letters unless there is only one angle at that letter. I cannot call this angle angle B because there are three different angles at B, and I don't know which one you're talking about. I don't know if you're talking about this angle, or the whole angle right here. So we name, most of the time we'll name our angles with three letters. The vertex is in the middle, right? So we would, when we trace it, we do D, B, P. That's this angle right here. The vertex of that angle's in the middle. So it would be congruent to, actually, okay, this is a technicality of geometry that's not really going to matter to you guys that much. If I put an M right there, meaning the measure of, I don't use congruent, I use the equal sign. If I didn't have the M, I would use the congruent sign. It's not going to matter that much to you guys, one way or the other, but measure of angle EBP. So that's these two angles right here are congruent to each other. I will also have FCP is going to be equal to the measure of angle, let's see, FCP is here, ECP. There. You can also call that angle PCE. C has to stay in the middle, but the P and the E can go in either place. And then last, we would have FAP is equal to the measure of angle DAP. Okay, questions? right? Okay, so a similar problem to the one we had before, but this time we know the end center. So this is the end center. End center, I know, is going to be comprised of angle bisectors. These lines that cut the angles of the triangle in half. So if that is an angle bisector, and this is 28, what is measure of angle PLO? What's this angle right here? Angle is the angle right here is 28 degrees. Because these two angles right here, that's 28 degrees. And this is also 28 degrees. Because the angle bisectors cut those angles in half. This angle right here is 39. What would this angle up here be? MJP. What is it? That's also 39 degrees. Can we figure out these angles right here? We don't know either one of them. So we can't write, we can, but not yet. Okay? Okay? So the first angle it asks us for, oh wait, I should also do this. If this side right here is 13, I said on the end center, that length to the side, it's the same for all of your pieces. So those should all be 13. 13, this one's 13, because they told us it was 13, and this one's 13. So they ask us for MJP. MJP is right here. It's 39 degrees. All right, now they're going to ask us for JKL. That is, this whole angle right here that we're looking for. I don't have any of those angles. Any ideas on what I could do? J is 78. Okay, so this right here, that whole angle right there is 78. Okay, what else? L is 56, so this whole angle right here, which really we probably can't call it L, we got to call it like JLK, but I think I know what you're talking about there. So that's 56 degrees. All right, why is that helpful? Okay, how'd you get 74? Good, because the angles of a triangle must add up to be 180 degrees. So this angle here, and this angle here, and the angle they're asking us for have to add up to 180 degrees. So if I do 180 minus the 78 minus the 56, what did you say we got? 74? Is that right? It sounds wrong. 46 sounds more right. More righter. I think it should be 46 on that. So you may want to make yourself a note. The angles of a triangle add up to 180 degrees. If you have forgotten that, you might. All right, so then they ask us for NKP, which is this, it's half of that angle we just found. And since that's bisected, we would just take half. We're going to get 23 degrees there. All right, and then the last one, KLJ, is this whole angle here, and really, Drew already told us that whenever we were finding the one before that should be 56. Yes, what we're doing today is all going to be triangles. Okay, questions on the angle stuff so far? They're also going to ask us some sides here. So this is NP, is one of these little lines from the center here. They're all 13. So that one's 13. Then they're going to ask us for KM. Okay? And Sailor is saying 30. What made you say 30 for that? Okay? How do you know for sure those are the same? Or are you just going on looks? So this side is 13, this side is 13, right? They also share that middle side right there. And then their angles are going to be the same because, like, this is a right angle. So those two triangles have to be congruent to each other. So she is exactly right. That side right there is also going to be 30. Okay. Now they're asking us for KP, which is this line right here in the middle. How are we going to find that?
The 30 and the 13, you have to do something with that, right?
Uh-huh.
Is it Pythagorean theorem?
Yes, because this, if we look right here, we have a right triangle. So that's a squared plus b squared equals c squared. What is going to be our hypotenuse? Not 30. It's the side we don't know on this one. It's always across from your right angle right here. So you would do 13 squared plus 30 squared equals c squared or x squared. You can call it whatever there. But 13 and 30 are your legs on that, and the hypotenuse is the side you don't know. So 13 squared plus 30 squared is going to be 1069 equals c squared. You will square root that, and the square root of 1069 is going to be 32.696 if you round it to 3 decimal places there. Okay, questions? All right, the last one they ask us for is PL. It's very similar. We need to do Pythagorean theorem again for that. So we'll have, this time, 13 squared plus 24 squared, which is going to give us c squared. So 13 squared plus 24 squared is 745. Equal to your c squared. You're going to square root that. And you should get 27.295. Okay, here. Okay. All right. Let's see. Okay. So here's another example with an in center, which means that this angle, this angle is congruent to this angle. This angle is congruent to this angle. This angle is congruent to this angle. So if I'm trying to find x, I've got to know like what that angle is equal to, right? Which is possible because if this is 27, I know this is also 27 degrees. Meaning that whole angle right there is going to be 54 degrees. And if this is 19 down here, then this angle right here is also 19, meaning that this whole angle right here is going to be 38 degrees. So how could I find this angle right here, GEF, that whole angle in this corner? They add up to 180, right? So I could do 180 minus 54 minus 38 is 88 degrees. So that would be the whole angle right here. That's GEF. But I only want half of that. So this would be 44 and this would be 44 degrees. So if I am trying to find x, I know that 17x minus 7 has to equal 44. And so this should be a pretty basic equation for you to solve once you get to this point. Alex, how would we solve that? To get that x by itself, what would we do first? Nope. Add that 7 there. So I'll have 17x equals 51. And then what would I have to do, Alex? That 17 is right beside the x. It means it's multiplied by the x. How do we get rid of multiplying? Divide it. So I'm going to divide by 17. And so x equals 3 for that. Okay, questions? All right, we got 2 more types of centers that we got to look at. All right, this line right here on this triangle is called a median. A median is a segment joining a vertex to the midpoint of the opposite side. So this line right here that goes from the vertex to the middle of the other side is called a median. And your 3 medians of a triangle intersect at a point called the centroid. So in this picture right here, that middle point P is your centroid. Centroids are a little bit interesting because it is the center of mass for the triangle. So if you were to take this triangle, cut it out, and try to like balance it on the tip of a pencil, that centroid is the point where it would balance. If you put your pencil there, it would balance on that point, which is not the case for the circumcenter or the incenter. Those are not your centers of mass for that. So the medians for this would be, I'm going to highlight them here in pink, it would be BF also CD and AE. So these have sort of like a different sort of property about them whenever you're looking at the centroid. For the centroid, when you look at the median, the shorter piece of the median is going to be half of the bigger piece. Or we could say, if we double the shorter piece, it's the length of the bigger piece. So like right here, if I'm looking at BF, BP would equal 2 times FP. So BP right here should be twice the length of FP. The same would be true for the other medians. So CP should be twice the length of DP. And for the last one, AP is twice as long as PE or EP. There. And there is one more blank. And I don't know if there's something else supposed to go in there, but I don't think there is. But we might need to ask Miss Martin. if there was something else that was supposed to go in that line. I can't, as I was doing the problems, I couldn't find anything extra that you need to know, so I don't think so. Alright, so questions here? Alright, let's do problem or two with this. Alright, so this is our centroid right here, which means this piece is congruent to this piece is congruent to this piece is congruent to this piece, because much like the perpendicular bisectors, the medians also cut those sides in half. They're just not perpendicular. So it tells us JK, this whole side right here, is 22. That would mean JM would be 11 and MK would be 11. KN is 13, so this right here is 13. That means NL would also be 13. OL is 18, which means JO would also be 18. So for a lot of these that it's going to ask us, they're going to be very simple to find. KM is 11. There. NL is 13. KL is going to be the full length of this side right here, so 13 plus 13 would give us 26. JO is 18. JL would be all the way across that bottom side, which would be 18 plus 18, so 36 for those. Okay. The next one here, Z is the centroid here. This one's going to give us some different information. It's going to tell us WR, the whole thing right here, is 87, the length of the whole thing. So, it's also going to tell us SY. So this piece right here is 39. And it tells us that, let me just look at the color here, YT, this piece is going to be 48. So the harder parts to find for this right here are going to be like whenever you have the median itself. Our special properties told us that this short piece was going to be, if we doubled it, it would give us this piece, right? So if I kind of split this piece right here in half, then these three sections from here, from R to Z, from Z to this halfway point, and from this halfway point to W, all three of those should be equal to each other, right? So if I take 87 and divide it by 3, then this is 29, this is 29, and this is 29, right? I can do something similar over here with the YT. The whole thing is 48. If I cut this right here in half, all three of those pieces should be equal to each other. So 48 divided by 3 is going to be 16, so this should be 16, this should be 16, and this should be 16. All right. So we are running out of time, but just to show you, like it's going to ask you ZR right here, that would be 29. Don't pack up because I'm going to squeeze in center in here real quick. It might ask us like ZT, that would be 16 for that. All right, so in center, we're going to look at it really quickly. I'm sorry, not in center, ortho center. An altitude is the height of a triangle. It is the segment joining a vertex to the opposite side so that it is perpendicular. To that side. The three altitudes of a triangle intersect at a point called the orthocenter. So in this particular problem, DP, this piece right here, No, I'm sorry, not DP, DC. AE and BF are all altitudes, and the ortho center there would be P. There's not special properties that go with the ortho center. We just need to be able to identify it. Okay? We have not got far enough for you guys to do a lot with this. So what I want you guys to do for this packet here is I want you guys just to do the front page where you're going to decide for each one whether it's an in-center, ortho-center, centroid, or circumcenter.
So
Just the word, just the front page for your homework. You don't have to actually do the problems yet, just the front page. So you should just have for each one, like the first one, those are angle bisectors. Angle bisectors goes with in-center. So the in-center for that first one. Did everybody get one? Alright, we'll have a test on Thursday. And class is going to be short on Wednesday because of Veterans Day Assembly. So, smart breakfast Monday, Tuesday, and Thursday. Some of you, it would be good for you to be here.